Have you ever pondered where the elements that make up everything around us, and even ourselves, originated from? A question that takes us on a journey not just through space, but also through time. Back to the very beginning, the Big Bang. When the universe was born, it was a hot, dense sea of energy, and from this energy, the first atoms were formed. The simplest of all, hydrogen, along with helium, and trace amounts of lithium and beryllium. But the universe wasn't content with just these. It had a grander design in mind. It wanted complexity, diversity. And so the stars took on the role of cosmic foundries, churning out heavier elements. These celestial bodies are veritable powerhouses where the process of nuclear fusion takes place. The cores of stars, under immense pressure and temperature, convert hydrogen into helium. This nuclear reaction releases energy, the very energy that makes stars shine. Yet the stars were not done. They had more to offer. When they reach the end of their lives, they go out in a blaze of glory. Massive stars explode in cataclysmic events known as supernovae. These spectacular outbursts are not just a finale, but a beginning too. They are the birthplaces of heavier elements from iron up to uranium. These elements are flung out into the cosmos, scattered across the universe to be incorporated into molecular clouds. These clouds, in turn, give rise to new generations of stars and planetary systems. But stars aren't the only cosmic phenomena at play here. Collisions of neutron stars, active galactic nuclei, and other extreme cosmic events also contribute to the production of heavy elements in the universe. Accompanied by the emission of gamma rays, X-rays, and other forms of electromagnetic radiation, these events paint a vivid picture of element creation in the cosmos. So, from the simplest hydrogen atom to the complex uranium, every element has an awe-inspiring cosmic history. We are all truly made of star stuff. Let's journey into the heart of stars, the true foundries of elements. Picture this: stars in their fiery cores are busy laboratories. Through a process known as nuclear fusion, they convert the simplest atom, hydrogen, into helium. This process is no ordinary transformation. It's a dance of atomic nuclei coming together under immense pressure and temperature. As they merge, they release an incredible amount of energy, lighting up the cosmos and fueling the stars' glow. Now, let's consider the fate of massive stars. These stellar giants, nearing the end of their life cycle, stage a grand finale, a supernova explosion. This isn't just a spectacle of light and energy, it's a forge crafting heavier elements from iron to uranium. These elements are then hurled into the vast expanse of space, sowing the seeds for future stars and planetary systems. In the spectacular death of stars, new elements are born and scattered across the cosmos. Beyond the stars, other cosmic phenomena also play a part in the creation of elements. Extreme cosmic events like the cataclysmic collision of neutron stars and the intense activity within galactic nuclei are factories for the production of heavy elements. These violent high-energy events forge elements heavier than iron up to uranium under conditions too extreme for stars to replicate. These cosmic crucibles also put on quite the light show. Their violent reactions release vast amounts of energy, manifesting as gamma rays, X-rays, and other forms of electromagnetic radiation. These signals traverse the vast cosmic distances and reach our telescopes, providing astronomers with a window into these extraordinary events. Through these processes, the universe continues its grand alchemy, cooking up the elements that make up the world around us and even the atoms in our bodies. Thus, the elements we find on Earth, and indeed across the universe, bear a profound cosmic origin, intricately linked to the evolution and dynamics of stars, galaxies, and large-scale structures.